Today we're continuing on in section 3.2, solving two-step equations. Yesterday we did some problems that would take 2 steps to solve. Today we're going to look at some more typical problems though that you're going to see when we refer to two-step equations. Here's what we're talking about is the examples we're going to go through today. All 3 of those bullet points that I brought up on the first day of solving equations are still going to be true, but even number 3 will be even a little important now, as you'll see here in a second. But I'm still going to focus on number 1 for sure. We need to isolate the variable. That's what we do when we solve an equation. We isolate the variable. We get it by itself. So my answer looks something like this: x equals 7, or again x equals 2. Okay, where my variable is all by itself on one side, the answer is all by itself on the other. So that's still what I'm looking to do. We're still going to do bullet point number 2, where we're looking to work with inverse operations. If they're adding something to the side of the variable, I'm going to subtract something. If they're dividing something to the variable, I'm going to multiply instead. So we're still going to look to work with inverse operations. And as a reminder, we still always do the same thing to both sides of an equation. That keeps our equation balanced, and that's what enables us to actually solve the equation. But this third bullet point I talked about in the first day is going to be even a little more important now. We're looking to work backwards to the problem, or sometimes what I mean by that, people are actually talking about, is we work reverse through PEMDAS. When we were doing order of operations problems, we'd start with parentheses and then move to exponents and so on through the problem. But now when we're solving an equation, we usually look to start on this end of PEMDAS, really. We're going to look to add or subtract something first, and then maybe multiply or divide. And that's usually the order that's going to help us solve an equation. I've got that step kind of written down here, or something I want you to put in your notes in red right here is essentially what I just said. With two-step equations, we will usually look to add or subtract something and then multiply or divide, and that's probably going to be the way that we're going to solve our equation. So I've got an example here below. We'll walk through this one first together, and I'll kind of show again what this means by working backwards to the problem. We did some solving equations already these first couple days. So again, this shouldn't look nothing different, except now that this problem has a little more going on in it. I have x divided by 2 plus 5 equals 11. I'm still going to do the same kind of steps we were doing those first days, though. I talked about drawing that line where the equal sign is. That reminds me that whatever I do to one side of the equation, I'm going to do that same exact thing to the other. That keeps my equation balanced, and that's what allows me to solve the equation. When I'm solving an equation, kind of like I have up here in red, okay, the first thing I'm usually look to do is add or subtract something from the variable, or from the variable side. Here's my variable x. In this problem, they're dividing by 2, and then they're also adding 5. So I'm going to look to deal with this part first, the adding 5. I'm going to look to deal with that part first, the add or subtract part of the equation. That's going to be the way that's probably going to get me more easily to my answer. So this says x divided by 2 plus 5. Again, I do the inverse of that. I'm going to subtract 5, and I'm going to do that to both sides of the equation. When I do that to the left side here, what happens is these 5's cancel out. Positive 5 minus 5 just gives me 0, so essentially those just go away. What's still left on this side of the equation is my x divided by 2, so I'm just going to bring that down and keep that on this side of the equation, so I still have x divided by 2. That equals whatever I have on the other side of my equation now, which is 11 minus 5. Well, that gives me 6. So now here's my new equation at this point. X divided by 2 equals 6. Now hopefully this looks kind of comfortable. This is something we did just a couple days ago, but this is a one-step equation. If it's x divided by 2, what I do is I multiply by 2 to both sides. That will cancel these 2's out on this side, so I just have x all by itself. On the other side is my answer, x equals 12. There's a way I can solve my two-step problem, again, usually by adding or subtracting something first to the problem, and then usually looking to multiply or divide to solve. I'll just walk us through a couple other examples here too. Again, sometimes many problems, as it says up here, sometimes the way we're going to solve it is by using 2 different operations, or there's two different operations that we're going to use to solve this equation. This first problem here, number 1 says 5x plus 9 equals 24. Again, to solve this equation, I'm going to draw my line. That reminds me to do the same thing on both sides of the equal sign whenever I do any kind of operation. Like I talked about on the previous page, I'm usually going to look to add or subtract something first. So this says 5x plus 9. Well, again, that's what I'm going to deal with first, is this plus 9 then. And what I'm going to do to get rid of that from the left side is I'm going to subtract 9. And what I have to do is I have to do that to both sides of the equation. When I do it over here, essentially the 9's go, because 9 minus 9 gives me 0. So those are essentially gone from my problem. All that's left now is my 5x, so I'm going to bring that down here. That's still on the left side of my equation, 5x. That equals 24 minus 9, which is 15. And now again, now I'm to a one-step problem, just like we did the first day. Divide both sides by 5, x equals 3. Problem number 2, 4y minus 4 equals 16. I draw my line to remind myself to do the same thing on both sides when I keep my equation balanced. Again, in this problem, they have y times 4 and they have y minus 4. So they're multiplying by 4 in this problem, and they're also subtracting. Again, which one am I going to deal with first? I'm going to deal with the adding or subtracting one first. When I'm solving the equation, that's usually the best step that's going to get me going in this problem to get me to the answer. So if they're subtracting 4, I'm going to add 4 to both sides. Why do I do it on the left side? Because that gets rid of the 4's over here. Now all that's left is this 4y. I can bring that down. 4y equals, what's left on the other side is 20. 4y equals 20 is a one-step problem. I have to do one more thing to solve the answer, or solve the problem here. Divide by 4 on both sides. I'm just going to bring my answer over here. Y equals, 20 divided by 4 gives me 5. So there's my solution to that problem. I'm just going to show us a few other examples here on this page as well, because as that previous page said, sometimes you have to do 2 different operations to solve your problem, your 2-step equation. Sometimes we have to do something we worked on these last couple weeks here, collecting like terms, and that's going to be my first step, and then maybe I'll be able to set up something like a one-step equation and solve that. So looking at this problem number 5, kind of for example, again, I'll draw my line because I'm going to solve this equation. It tells me to solve. So I got to somehow get x by itself on one side and my answer on the other. I'm going to draw my line still just like I've been doing to remind myself to do the same thing on both sides. But now if I look at the right side here, I see that I have 4x plus 7x. Again, like we worked on the past couple weeks, those are like terms. When I have them on the same side of the equation, I can just add them together like it says, just like combining like terms like we did in expressions. In the past, when I've had an expression that said 4x plus 7x, we've talked about just combining those, and that just gives me 11x. I can combine those to get that one term. I can do the same thing here in this equation. 4x plus 7x gives me 11x. And so on the left side, now I have 11x. On the other side, I have 121. Now it's just like a one-step equation. 11x equals 121. I'm going to divide both sides by 11. So x equals 11 in this case. Going to this next problem, number 6. Same kind of thing. I'm going to draw my line. On the left side here, I notice that I have 6w minus 2w. Those are like terms. And so I can just do essentially what it tells me to do with those terms. It says to subtract them. 6 minus 2 is 4, so this is 4w. When I collect like terms, I just essentially remember deal with these coefficients. This one tells me to subtract them. And I just keep that variable part with it, so it's 4w. That equals, well, in this case, negative 96. And now again, I've set up a one-step problem, which is much easier to solve. Divide both sides by 4. W equals negative 24. I'll go through 2 more here just to kind of make sure we got the idea on these last set of examples here, where I'm combining like terms. Number 7, negative 8p plus 5p equals negative 36. Draw my line. On the left side here, I have some like terms. Both those terms have the same variable part to them, negative 8p and 5p. So I can combine those two, and again, all you do really is take the coefficients and do what it tells you to do with them. In this case, it's add. So negative 8 plus 5 gives me negative 3, and I keep that variable part with it, so negative 3p equals negative 36. Now it's a one-step problem. I just have to divide both sides by negative 3 because that's what's multiplied to p over here. That'll cancel out the negative 3, so just p is left by itself on the left side. Negative 36 divided by negative 3 gives me positive 12. And my last example on this page, again, I'll draw my line. The x's are on the right side this time, but that's okay. I'm still going to follow the exact same steps. Okay, it doesn't matter whether they're on the left or the right. Either way, I can still solve and get x by itself. In this problem, again, I have like terms, negative 5x minus 8x. And again, remember, when there's a subtraction sign in front of a term, just think of it like negative 8x when you're combining it. So it's like negative 5x plus negative 8x. That's really what's happening here. Negative 5 plus negative 8 gives me negative 13, so negative 13x. And that equals 39 still on this left side. If I divide both sides by negative 13, on the right side I have x, on the left side I get negative 3, and you can leave it like this, but I like to switch it around. Usually we write the variable on the left side, So I'm going to write it like this, x equals -3. So there are some examples of solving different types of two-step equations. We solve some where we do different operations for each part, and some where we may have to collect like terms to solve it. But either way, all these problems have 2 steps to solve. All steps that we're fully capable of doing.